Hi, I'm George Woodbury from College of the Sequoias in Visalia, California, and in this video, we're going to go over solving introductory linear equations. So these are equations on this first page that only require one step to solve. We'll also take a look at some other equations that don't involve simplifying both sides first. So this first problem, solve x plus 7 equals 4. We see that the 7 is being added to x. We undo addition with subtraction. So I'm going to go ahead and subtract 7 from both sides of the equation. 7 minus 7 is 0, so that leaves us with x plus 0 on the left-hand side, but x plus 0 is just another way to write x. So that leaves x isolated on the left-hand side of the equation. 4 minus 7 on the right-hand side is negative 3, and so our solution appears to be x equals negative 3. And we can write that solution in a solution set with those curly brackets around the outside. We can also check our solution by substituting that value back in for x in the original equation. So if I put the negative 3 back in, negative 3 plus 7 should be equal to 4, and it is. So that value gives us the solution of the equation. In the second problem, x minus 9 equals 16, the inverse operation for subtraction is addition. So we can add 9 to both sides of the equation. Whatever we're doing on one side of the equation, we want to do the same thing on the other side as well. Negative 9 plus 9 is 0. That leaves x isolated on the left-hand side. And on the right-hand side, 16 plus 9 is 25. A quick check. If we put in the 25 for x, 25 minus 9 is 16, so that one does work. The next two problems involve coefficients for the variable, where we're multiplying the variable by a number. In the first one, we've got negative 6x equals 42. That negative 6 is attached to x through multiplication. The inverse operation for multiplication is division. So we're going to divide both sides of the equation by negative 6. Negative 6 divided by negative 6 is positive 1. So that leaves 1 times x on the left-hand side, which is just another way to say x. So again, we've isolated the variable. Now to find the solution, I need to divide 42 by negative 6 on that right-hand side. And a positive divided by a negative is a negative result, and 42 divided by 6 is 7. So our solution is negative 7. And again, another quick check. Last one I'm going to do in this video. If I put the negative 7 back in for x, I've got negative 6 times negative 7, and a negative times a negative is positive, and 6 times 7 is 42. Problem 4, 8x equals 30. This looks similar to problem 3, except we're dividing by a positive number. But when we divide both sides by 8, things turn out a little differently this time. 8 divided by 8 is 1. So we are left with x on the right-hand side, but 8 does not divide into 30 evenly. So here we want to simplify that fraction to lowest terms, and we know that 30 and 8 have a common factor of 2 that we can divide out. Sometimes we refer to this as reducing the fraction, but we're simplifying it to lowest terms. 30 divided by 2 is 15, 8 divided by 2 is 4, and that cannot be simplified any further. The only factors of 15 other than 1 are 3 and 5, and neither of those are a factor of 4, so we can't simplify this any further. Our solution set has that improper fraction, 15 over 4. Now, pay attention to the directions, because if it asks for a mixed number, you could change it to a mixed number. If it asks for a decimal, you could change that to a decimal. But in general, leaving it as an improper fraction is the best way to go. 2 more to go. These both involve more than one step. So here in problem 5, I have 3x minus 19 equals negative 7. So I've got 2 numbers attached to the variable here. I've got a 3 attached to it through multiplication, and I've got a 19 attached to it through subtraction. And we've got to figure out which one of those is more closely related to x, which one is less closely related. That's the one we're going to get rid of first. And if you think about if I gave you a number to plug in to check the equation, if you were going to substitute, let's say 10 for x, you would have 3 times 10 minus 19. Order of operations says multiply and then subtract. we solve in the reverse order. We break things apart in the reverse order. So the first step here is to add 19 to both sides. And negative 19 plus 19 is 0, so that basically disappears, leaving 3x on the left-hand side equal to negative 7 plus 19, that's positive 12. In general, if you have an equation of this form, ax plus b equals c, where b and c are just constant terms, you want to get all the constant terms away from the variable term, move it to the other side. Then you'll be left with an equation like problem 3 and 4 that we did already. I've got a number times x equals another number. I can solve this by dividing. Here I'm going to divide both sides by 3, and I'm left with x is equal to 4. Now, one thing I want you to notice, we took an equation that we hadn't done before, and we changed it into an equation that looked like one that we had done before. And that's really the goal in math, is to take things that you haven't been able to do before and try to convert them into something that you have done before. If you wanted to check, if you plugged in the 4, 3 times 4 is 12, 12 minus 19 is negative 7. All right, one last one for this video. And what's different in problem 6, and I'll leave it there for just a moment, is that this time we have variables on both sides. Right? I've got a 5x on the left-hand side, 7x on the right-hand side. That's different. We haven't seen that before. We want to collect all the variable terms to one side. And in general, the first step in solving equations is to simplify both sides. And we haven't seen that yet. I'll talk about that in the next video. Then you want to collect all the variables on one side. So collect all variable terms on one side. Once that's done, we want all the constant terms on the other side, and then we can finish that by dividing. Finally, step 5, I'm not going to write it down, but step 5 would be to check your solution. Right? That's the one advantage we have in math. When we think we have the answer, we can always check to make sure that it's right. Let's take a look at problem 6. Again, I can either move all the variable terms to the left or to the right-hand side. It doesn't matter. And a lot of people like to move them to the left-hand side. Always get your x's on the left-hand side. I don't know that that's always the best idea. Here, I'm going to start by moving the 5x to the right-hand side. And I'm going to do that by subtracting it. It's a positive 5x. So if I subtract 5x, 5x minus 5x is 0. That part disappears. I'm left with 17 on the left-hand side. And on the right-hand side, 7x minus 5x is 2x. So I have 2x minus 39. The advantage of moving the 5x becomes apparent now, because in a moment, I've got 2x. I'm going to have to divide both sides by 2 at some point, and it's easier, meaning you're less likely to make a mistake when dividing by a positive number than when you have a negative coefficient. So if I had subtracted 7x from both sides, I would have had a negative 2x on the left. I've got to divide by negative 2, and I've got to make sure that I don't lose that sign somewhere along the way. So it's a little safer to try to move the variable terms to where the coefficient will end up being positive. This is basically like the last one. I need to get rid of the constant term from the right-hand side, so I'm going to add 39 to both sides, and that gets me to 56 equals 2x, which I can then solve by dividing both sides by 2. On your calculator, 56 divided by 2 is 28. So I have 28 equals x. That's the same as x equals 28. So if you're uncomfortable about having the variable on the right-hand side, you can now rewrite it so it's on the left-hand side, and our solution set contains the number 28. All right, that's it for what I would call simple or introductory linear equations. In the next video, we'll take a look at some equations where you have to simplify both sides of the equation first.